Good evening, welcome to another short video. So for this video, we're going to be doing a question from a past scholarship exam for calculus for 2000. But in terms of this question, I feel like it's more, these days, it's probably more just a standard level 3 question. But that's totally fine, so we just get into it. So Marcia and Hemi believe that they proved that you inscribe a rectangle in a circle so that both its diagonals are the diameters. The maximum error will occur when the rectangle is a square. So determine they're correct by using calculus. Right, so for these questions where they're telling you to area and all that stuff, I highly recommend you when you approach these questions just to draw a quick diagram first. It doesn't have to be a really pretty diagram, but in this case, since I have a nice tool here, I can just get an image of a circle. And then we see that if we draw a rectangle, inscribe a rectangle, and just, sorry, it's not very neat, but if we draw a rectangle in the circle, we can call this the height, and this side we can call it the base, if it's going to let me. Right, there it is. Therefore, we can say the area is equal to the base times the height. And if we draw a line from one diagonal to the other, we can call this the diameter. We call it D. Sorry, it's not letting me. Okay, we just know that diagonal is B. So diagonal is equal to D. So we can say that by the Pythagoras theorem, that's a right angle. So we can say that h squared plus b squared equals to d squared. And we can make any one of these variables in terms of each other. So I'll just choose, doesn't matter which one you choose, but in this case, I'll just choose h squared equals d squared minus b squared. So therefore, we can say that h equals to the square root of d squared minus b squared. And it's the positive square root since height is a positive number. So we can say the area is equal to the base multiplied by the height, which we found was d squared minus b squared. And we can write area equals to, we can move the b inside the square root to make out, so we don't have to use the product rule. So we can say that this equals to b squared d squared minus b to the power 4. And now we can say that dA and dB, find the derivative with respect to b. That equals to 1/2 times b squared d squared minus b to the power 4 to the power of negative 1/2 times the derivative of the inside function, which in this case is 2b d squared minus 4b to the power 3. And for maximum, we know that dA dB equals to 0. Therefore, we can say that 1/2 times 2b d squared minus 4b cubed equals to 0. And we can say that b d squared minus 2b cubed equals to 0. We can divide everything by b, divide through. So d squared minus 2b squared equals to 0. So therefore, 2b squared equals to d squared. And if we can say that b squared equals to d squared over 2, and therefore b equals to positive or negative d over root 2. But since b is strictly positive, b is strictly positive, so negative d over root 2 is not a solution, or it's just not valid in this context. So therefore, we know that b equals to d over root 2. We find that h squared equals to d squared minus b squared. H squared equals to d squared minus b squared. And therefore, h squared equals to d squared minus d squared over 2. So therefore, h squared also equals to d squared over 2. So therefore, h equals to d over root 2. And as we can see here, h equals to b. So this is indeed a square. Alright, and if we can actually calculate the area if we want, if we come back here. So area equals to base times height, which is d over root 2 times d over root 2. And that equals to d squared over 2. So that's the maximum area. So therefore, since Hemi and who else was it? Marcia and Hemi, they are correct since d over root 2 both are d over root 2. So it is a square. So therefore, they are correct. So thank you for watching this video. I do hope you enjoyed, and I hope to see you on the next one.